Hello everyone. In this video, we are going to look at some more aspects related to functions. Okay. The first thing that we are going to look at is type conversion functions. Fine. So one function that we have looked at earlier is the type function. For example, if I want to know the type of this value 3, I can use the type function. Let me just print what is the type of 3. If I print this, you can see that this is of type int. Similarly, I can also find the type of a variable. If I say x is 4.0 and if I print type of x, so you can see that x is of type float. Fine. So now there are some functions where we can convert between these different types. So for example, if you want to convert a value of type into a value of type float, you can use the float function. Okay, so if I say x equals 3, fine. Now what I'll do is I'll say type of, or let me do this, I'll say y equals float of x. Okay, so float is a function that I'm calling with on this variable x. I'm passing x as the argument and I'm calling this function float. So let us look at what are the types of x and y. So print type of x, print type of y. So you can see that x is of type int and y is of type float. Now if I want to convert it back to an int, I can again use the int function, int of y. So I'm saying I'm calling this function int on this value y, and whatever is returned, whatever is the result of this function, that I'm assigning to this variable z. So now what I would expect is the z should be of type int, right? Because I'm using int function to convert y back to an int. So let me print the type of z. So you can see that z is of type int. Okay. Similarly, you can convert functions between string and a number also. Okay. So x is equal to 3 is an int right now, right? So if I say a equals str, so str is a function which converts value of any other data type to a string. So if I say strx and if I say print type of a, so now we would expect that this should be a string. Okay. Similarly, if I want to convert it back to an int, I'll say int of a, and if I say print type of b, so you can see that I've converted it back to an int. Okay, so these are the type conversion functions. So one thing that I want to let you know is whenever you use the input function, so if I say, let me say s equals input, enter a number. Okay, let me just put this in another cell. Okay, what I'm doing here is I'm taking an input. So let me check. Stop this. Okay, so what I want to see is what is the type of s. All right, so now let me run this. So let me enter a number 23. So you may expect that 23 should be of type int, right? But let us see what it actually is. So it is of type string. Okay, let us try something else. So instead of a number, even though it says enter a number, let me enter a string. Suppose if I enter this, so again the type of s is of type string. So the thing that you need to remember is this input function will always return a value of type string. The result of input function is always a value of type string. Okay, So now if you want to take a number as input and do some mathematical operations on it, so what you would have to do is first convert it into a value of a number type, either an int or float or any other number type. So you have to do the type conversion first. So here I take the input here first, and then what I do is, or in the same thing, what you can do is just pass the result of this input function to the int function. All right. So now what it will do is, so whatever input will be passed to the int function, and that result will be result of this int function will be stored in S. Fine. So now I would expect that the type of S should be a number. Fine. Or it is a number type. It is basically of int data type. So why should we do this conversion? So for example, if I take two numbers as inputs, so let me say I take S and T as inputs. So input, enter another number. So now what I'll do is I'll print S plus T. So let me say 12 and 13. So you see that S plus T. So when they're both numbers, what you would expect is mathematical addition should happen. So 12 plus 13, you expect the result to be 25. But here you see the result is 1213 because here mathematical addition is not taking place. String addition is taking place, which is basically string concatenation. Like one string is just getting appended to the first string, and the second string are just getting concatenated or placed one after another. Okay. So if I want to actually do the mathematical operation, I will have to convert them into numbers first. So what this means is that this plus operation has different meaning for values of different data types. So I have to make sure that my data is of the right type before I actually apply this operation. So now using this int function, what will happen is both S and T will get converted into ints. Now if I run this, if I say 12 and if I say 13, so you'll see that the sum is what I expect it to be. It is 25. Okay. Now moving on. The next thing that we're going to look at is some math functions. Okay. So here what I'm trying to do is I'm trying to convert degrees into radians, and I'm using this math.py function. Okay. So in programming, why software has grown so rapidly is because of reusability of code. Okay, if I write some code, then if I share it to someone, they are able to use my code, the functions that I have written, they are able to use, so I can build on top of someone else's work. Okay, so how do I actually share the code that I have written with others? So it is done using what we call as libraries. Okay, libraries of code or modules. So I can write a library of code which has lots of useful functions, and I can give it to someone else. So if someone else is building an application which uh, needs to use those functions, they need not write everything from scratch. They can use that library as is. Okay, so in a similar way, Python has many inbuilt libraries. So one of those is the math library. Okay, so how do you actually use the functions inside that library? First you have to import that library. So for that you use the import keyword. Okay, so what I'll say is, first I'll say import math. Once I say import math, whatever functions and constants are inside this math library, they're all available to me. Okay, so first I'll have to say import math. For example, if I don't say this import math and if I try to run this, so I get this error, name math is not defined. Okay, to avoid this, what I'll do is I'll say import math. Now if I run this, so that error goes away. So here I'm just demonstrating the use of some math functions. So for example, if I have degrees is 45, okay, I have to convert it into radians. So what I'm doing is I'm dividing it by 360 and multiplying it by 2 pi. Okay, so but I do not have the exact value of pi. I may not remember the value of pi, but this math library has this constant pi inside it, math.py. So pi is a constant inside the math library. To be able to use that, this is the notation that I use: name of the library dot and name of that constant. So okay, similarly, now if I want the sine value of this angle, okay, I have an angle in radians and I need its sine value. So math has a handy function called sine function. Okay, so how do I use this? I'll have to first write the name of the library dot sine, and then I can use this function. I just have to pass the value of in radians. And so one thing that you need to remember is the sine and cos functions in these libraries usually take the angle values in radians and not degrees. Okay, since I've converted this into radians, now I can pass this value. Similarly, here I'm showing another example of finding a square root. Okay, so I'm comparing two things. So we know that sine of 45 degrees is 1 upon square root 2, right? So the sine of 45 degrees is 1 upon square root of 2, which is square root of 2 divided by 2. Okay, I could also have written this as 1 divided by square root of 2. So I want to compare what are the two values, one which I'm getting using the sine function and another from this. So if I run this, so you can see that I'm getting the same value in both cases. That is how you use the math module. If you want to know all the functions which are present in the math module, so just search Google for, so this is the official documentation. If you go here, select your Python version from this, and you'll get all the functions which are available to you. Okay, there are lots of functions. Fine. Next, let us look at function composition. So you can call one function from within another. This ability is called composition. Okay, so what I'm doing here is, first I'm taking this variable x1 and I'm assigning to it the value of some value in radians. Okay, sine of some value in radians. So I've taken the degrees, converted into radians, and now I am assigning this value to x1. Okay, this is the value of x1. Now what I'm doing is, uh, here I'm using function composition. First what I did is I took the log of x1 plus 1, and then I'm raising it to the power e. So what is exponent, like if you raise the logarithm of something to the power e, you get the same number back, right? So I expect to get x1 plus 1, which is this. Okay, so the more important thing to note here is, you can see here that I'm calling this function math.log, and whatever is the result, that I'm immediately calling on the function math.x. So within call to one function, I'm actually calling another function. So this is called as function composition. Okay, now let us look at the flow of execution of functions. So a function has to be defined before its first use. Okay, so what happens if I don't define a function? So let us see. Uh, so let me create two code cells. In this, what I'll do is I'll define a simple add function. I'll say print x plus y. Okay, so now I have written the code for this function here, but I have not executed this cell. Okay, now here if I say add 2 comma 3, So you see that I get this error, name add is not defined. Why this I'm getting this error? Because I have not yet defined this function. To define this function, I actually have to execute the code cell in which the function is defined. So if suppose if I run this cell, now if I run this, you see that now there is no error, and the function is running as it is supposed to. So first you must define a function before you can actually execute it. But another thing to remember is defining a function does not actually execute the code which is written inside it. Okay, defining a function creates a function object. So statements inside a function are not executed until the function is called. Defining a function only creates a variable with the same name. Okay, so when I ran this piece of code, so what happened was I created a variable with name add, okay, which refers to this function. So I can actually look at the type of this variable. If I say type of add, you can see that it is of type function. Okay, and just like any other variable, I can assign this uh, value of this variable to any other variable like y, and now the type of y is also a function. So it is the same function, so I can actually say y of 2 comma 3, and it will actually execute that function. Okay, so a function value is just like any other value in that sense. A function call is like a detour in the flow of execution. So instead of going to the next statement, the flow jumps to the body of the function, executes all the statements there, and then comes back to pick up where it left off. Okay, so what we are saying here, so suppose if I have x equals 2, y equals 4, here I'll say add x comma y, and then I'll say print x into y. Okay, so what happens if I run this cell is, first I'll run these two statements. I'll assign the value of 2 to x and 4 to y. Next, when I encounter this function call add x comma y, what will happen is immediately this function takes the flow of execution. So what is the flow of execution? First I executed this statement, this statement. Now when I come here, what I'll do is I'll actually go to the body of the function. So I'll go here and then I'll execute this statement. Or if I have multiple statements here, then I'll execute all those statements, and after they are done, then I'll come back. So I left from this line 3, so I'll come back again to line 4 and I'll execute this statement. Okay, so that is how the flow works. So this can get very complicated when like functions are calling other functions which are calling other functions, but to actually be able to effectively debug your programs, you must be able to visualize how this flow of execution is happening. Okay, another minor point is about arguments and parameters. So the values that are passed to a function are called arguments. Okay, so for example, in this example that we had earlier, add x comma y, so x and y are arguments to this function add. Fine, arguments are assigned to parameters inside the function body. So just for removing ambiguity, let me call this a and b. Okay, so here a and b are arguments to function add, and inside the function body, so these a and b, they get assigned to these variables x and y. Okay, so these are called the parameters of the function. Fine, so these parameters of a function are local to this function, so they exist only within the scope of the function. Only the function is able to see them, and as soon as the the flow of execution exits from the function, those variables are completely destroyed and are inaccessible. So variables and parameters are local. So these are x and y are special variables which are called parameters, but other than x and y, I can also have other variables like inside a function, like for example sum underscore. I've created this variable inside a function where I'm adding these two parameters x and y, and I'm printing this. Fine. So all of these variables x, y, and sum, all these three get destroyed as soon as I finish executing this statement and exit from the function. So this you must have seen earlier also. Next is fruitful functions and void functions. Okay. So this is a very important distinction that you must understand. So some functions yield or return results. These this is not a technical term, but we can call them as fruitful functions. They give some fruit or result. Other functions, they perform some actions but they don't return a value. Okay, these are called void functions. So for example, again, if I define this add function, I'll say add x comma y. So I can define it in two ways. Let me say this is add one, add fruitful. Here I'll say return x plus y, add void, print x plus y. So what is the difference? So if I say add void, so let me print this. So what is happening here, and also let me print value of a is so value of a is 5 and b is none. So what is happening here? So in the first function, I'm actually using this return statement. Okay, so whenever I encounter this return statement in a function, what happens is immediately I'll exit from the function, and whoever is calling that function, at that place I will return this value, whatever value I want to return. So here, for example, I'm returning x plus y. So that is one way to exit a function. Another way to exit a function is just when the body terminates, like there are no more statements left, but I'm not using the return statement anywhere inside the function. So for example, in this add void, I have a print statement. So I'm actually performing some action inside the function, but I'm not returning anything. So this is called as a void function, whereas here I'm returning something to the place where this function was called. So this is called as a fruitful function. So if I want to store the result of doing some processing inside a function, I must always use these fruitful functions. Okay, if I want to, here what processing did I do here I added two values. So now if I want to save this result, so what I must do is I must assign this value to some variable. So if I simply run this, for example, so what will happen is the value will be returned here, but because I'm not capturing this value inside any variable, this will be lost forever. But instead of that, if I actually store it in this variable a, so now I have saved this in the memory at some place, and I can use it in some other computation next. But this function add void, this does not return anything. So when I try to assign the result of this to any variable, so what happens is I get a special value called none. Okay, so you can see that the value of b is none. So all void functions which do not actually explicitly return any value, they will return value of this type none. So this is something which many beginners get confused about. They print stuff inside their functions, and they expect that this will be returned to the place where the function was called, but this does not happen. You have to use the return statement, and only the values that you're using with the return statement will be returned. Okay, next let us look at a variation of using this import. So we have seen at how to import modules using the import keyword. You just have to uh, say import math. For example, here we were importing math, so you just have to say import math. Now we saw that suppose if you want to use this constant inside the math module, you have to say math.py. Okay, but saying this again and again, like each time you want to use py, using this notation math.py, it may become cumbersome and very long. Okay, so instead of that, if you want to simply use the constant py, so you can say from math import py. Okay, so what that does is, uh, now this value or this variable pi is directly available for you to use. Okay, so one way is I'll say import math and I'll say print math.py. Okay, now here if I try to say print pi, this will be an error, name pi is not defined. But suppose I say from math import pi, and if I say print pi, so now there is no error. Okay, so if you want to avoid using this long notation of math.py, you can use the from notation, from math import pi, and now you can directly use this variable pi. So another thing is, suppose you want to import everything that is there, all the functions and all the variables which are there in a particular module, so you can say from math import star. So star refers to uh, star is saying that import everything which is there in that function. So you have pi, and you have e, you have sine of something, uh, maybe 2 pi. So both these variables and these functions, all of them are available to us once we say from math import star. Okay, so the advantage of importing everything is that code can be more concise. You can avoid writing this math dot before each and every function and variable. But disadvantage is conflict between names defined in different modules. Okay, so there may be cases where you have two functions with the same name but different use case in two different modules. Okay, now if you import both of them using star, then there will be a conflict in the names. So like this is an issue which you may not encounter very frequently, but something to keep in mind is that you may run into conflicts of names if you're importing everything from multiple libraries. Okay, so this was a video covering some more aspects of functions. That is all. Thank you.